Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, not all cores are created equal in the cloud, with special guest Stephen Holt. All right, Stephen, tell me a little bit about your background. You're new at Intel. Intel's been hiring cloud solution architects to help our customers move intelligently to the right cloud instances for their workloads. What qualifies you for this?
Well, I've been dealing with the cloud for a number of years. I've been with IBM, introducing their database products into the cloud, and through some of their acquisitions, I've been with a number of startups deploying database as a service to multiple cloud platforms, cloud solution providers. And I've had a very long history with databases in general, but like I said, in the last 7 or 8 years, focusing on cloud, leveraging the cloud, getting the most out of the cloud for all the customers that I've dealt with in my career.
What would you say has been some of the most difficult things that you've run into with helping customers move to the cloud?
Wow. So I'd probably say that, actually the pricing, the movement, the expectations, that setting the expectations for the move. There's a lot of benefits around agility, time to market, innovative power, but cost. A lot of folks expect cost to be, I'm hoping to dramatically decrease cost. I'm getting rid of a lot of IT. That is generally not the case. It's really the agility aspect.
Really interesting, because cost, everyone, all the cloud service providers say, hey, it's cheaper to run in my cloud. But I've heard this from several other cloud service architects or solution architects. Costs, if you don't have control of it, it can run completely out of your budget very quickly. So it is an issue then. Oh,
absolutely. Absolutely. And it's becoming a cloud solution architect, I've discovered 2 different things. One is that change is a constant. So things change all the time with cloud solution providers. The features, the functions, the abilities, and the competitiveness between them. There's constant change. And the other one is that ignorance is bliss. As being a customer of the cloud providers, I just thought things like a core, a vCPU was just another resource, another hardware resource that you could just allocate and use in this. And it was all the same across the board. And then when you get those bills that show the ever increasing number and your workload isn't optimized, and intelligence is a curse, but you get smart very quickly when you.
So that's interesting, because a lot of people migrating to cloud do the lift and shift. And what you're telling me is lift and shift is very expensive.
Yeah. Oh, absolutely. There's some workloads that don't belong in the cloud, and they're pretty obvious. Some older applications, legacy applications, mainframe applications. Imagine the work and the thought and just everything that has to go into not just it's not a lift and shift. You have to refactor the application and re-platform it onto a completely different platform. Yeah, there's not a lot of forethought, and you just pay for it on the back end.
So you've done a lot of research on the instances in the different clouds and making sure that you're picking the right instance, right? For like performance, if I can squeeze out 25% performance improvement, I can actually decrease my cost.
Oh, absolutely.
Possibly,
oh,
right?
Absolutely. Yeah. I multiply that by 1,000 instances. You've saved a lot of money. Let's just say a lot of money.
Right. So this tells me that not all cores, these virtual CPUs, are equal, because we would think it's almost like a utility, like electricity, right? In my electrical wall, every electron I get to run my stuff is equal, right?
Yeah.
They're fungible. They're interchangeable. Not true for virtual cores, correct? That's what you've
Yes.
learned.
Oh, absolutely, absolutely. And with AWS, they've got the M4, the Broadwell, Intel's Broadwell. They've got the M5, which is a mix of Cascade Lake and Skylake. And depending on the workloads can take advantage of those platforms very differently. And it could be like we said, a huge amount of money that could be saved if you place things correctly.
All right, so let's talk a little bit about the performance testing that you have done. You've done some core mark performance testing. What did you find there? What kind of performance? I mean, what's the deal here?
So the core mark one was interesting because it was by rumor that we heard that one of the cloud management providers had an algorithm for recommending platforms to their customers, or maybe it was an SI, I can't remember. But they leveraged the core mark as part of their algorithm. And the core mark is a product, it's a single-threaded application. It just tests register moves and simple additions for any number of CPUs. And as you can see from the graph, I'm assuming you're showing the graph now, but you can see that across Broadwell, Skylake, and Cascade Lake, 3 generations of Intel processors, there's very little difference. I'd say within 7 to 10% difference between those processors. And it wasn't a very effective way of measuring the differences in the processors themselves. And so their recommendation from this, again, from this company was erroneous, that they were leading other customers towards.
So you're telling me the core mark performance benchmark really doesn't give you the full system performance that you're looking at? Because
that's correct.
We know from Broadwell to Cascade Lake, there is major performance differences.
Huge performances. And when we're talking about workloads, some of the workloads gain significantly going from one generation to the next. So we performed additional tests on real workloads. And I'm a database guy, so I focused on open source, or we focused on open source databases, mostly PostgreSQL and MySQL. And we found definitely a trend that going from Broadwell to Skylake and Cascade Lake, selecting in the AWS environment, the M4, which was Broadwell, the M5, which was a mix, but we made sure it was on Skylake. It was either Skylake or Cascade Lake. And then the NVMe attached M5D was always Cascade Lake. So we could measure or do the differences between the performance.
So what did you see? I mean, was it was better than the...
Oh yeah, I mean, the Cascade Lake environment was 3 times better than the Broadwell environment for open source. And that makes sense because there are a number of improvements and memory access and things that have been explained to me. And again, I'm new at Intel. I'm fairly new, so I'm not that up to date with the processor technology, but it makes a huge difference with the advances, not just speed, but the on-chip advancements that take advantage of the low latency access, low latency workloads, basically. So it's and you can see, I mean, you can see there was a 2 times and 3 times better performance going up to generations based on the workload.
So that tells me though that workload and core need to be looked at together when deciding which instance you should be using.
Absolutely.
That you can't just vanilla paste, I'm going to use the cheapest, the M4 16X large for everything.
Yep.
That
Absolutely.
just doesn't make sense is what you're saying.
Absolutely. And when I was a customer, I thought, again, these were just resources. And if Amazon said, here, we've got another vCPU that you can use, it's 10% less, and I think that's great, let's use that one. But the way that they would work, they'd take these other processors, they pack all these cores on them, and you'd be moving from an environment where you're one of 48 virtual machines on a box to one where there's 128 virtual machines on a box, and your access to memory is limited. You're getting possibly 60% less performance, but you're paying 10% less. So it just doesn't work out.
So
You've got to realize.
Yeah, what this tells me, Steve, is that we need to not, when we're outsourcing, we talked about this at the beginning, we think that we're going to decrease our cost. That's one of the reasons why we do it. And one of those costs that we tend to get rid of is systems architects, right? I don't need that person that understands how systems are put together or anything like that. Sounds to me like you still do.
Oh, absolutely.
But
absolutely.
they're no longer racking and stacking machines. They can now do that virtually. And it sounds to me like they need to understand what these different instances provide for different workloads.
Absolutely. And it's like I said, ignorance is bliss, but then the bill comes and you become smart pretty quickly.
Very interesting. So is there a place that shows, hey, which workloads run best on which instances out there? Are there any resources like that out there for the different clouds yet?
That's a great question. We Intel, we're trying to create one. We do have some general guidelines. We have cloud solution architects that help guide folks, that help talk to them. I personally encourage a lot of testing. I mean, folks have to understand where they're placing stuff, and that brings us to actually another point that I want to get across, and that's actually validating what you're getting from a cloud solution provider. You're expecting a certain amount of resources and performance, but sometimes it's just not what you don't get what you expect. And it's worth validating.
Wait. No, I don't believe you.
Yeah.
I do believe you. I'm being sarcastic. But you're telling me if I run a workload on a specific instance that I'm going to get different performance out of that if I run it several times on other instances of that same type.
Yeah. So now we did some testing, and again, I thoroughly encourage folks to test and benchmark themselves. But I did some, we did some, and we would find a workload on a fresh install or a fresh instance, a 64 core, 64 vCPU instance. We would test it, get a certain number, and then we would instantiate another instance and do the same test again. And we got dramatically varying results from the same test each time. And I mean, the only way we can figure is that, again, there may be a mix of processors that may be offered at that tier level, Skylake and Cascade Lake, and each have one has advantages over the other. But then there's the actual block storage attachment, where there could be some distance and some additional latencies to that block storage. And again, I'm looking at database workloads specifically because I am the database guy. But yeah, the performance could vary dramatically, and I highly encourage folks to make sure that the system that they instantiate meets their expectations.
I love how you said that it's not just the CPU. It's the whole system. So in your own data center, you optimize your systems for the types of workloads that you have.
Yep.
Right? Sounds to me like you need to do the same in the cloud. You can't just ignore it. I mean, I think a lot of people just feel, well, I just fire up an instance and I'm fine. But what you have found is the predictability, and we call that predicted performance, is in the tank. And that could be several different factors. One that we always talk about is noisy neighbor.
Yep.
Which could be someone else writing on the same drive you're writing on, or on the same network, or even on the same machine. And you have zero control over that.
Oh, absolutely. And it's all about the expectation. And again, that goes back to ignorance really was bliss. But then when you start figuring things out, it's quite a lot of work, and ask for help. And that's where folks like myself and my other peers can definitely assist and help folks understand what they're doing, where they're placing stuff, and how to optimize in their environment.
Now,
Absolutely.
what was one of the tricks that you learned from the database, the system as a whole, not just testing, hey, everything's on the same system? You mentioned something to me earlier about you tend to get better predictive performance by using like NVMe drives on those instances instead of just your generic drive space that comes.
Yeah, I don't know if it's gaming the system, but we found that we were more or less guaranteed a Cascade Lake performance when we selected NVMe drives. So in AWS, it would be the M5D or the R5D. Cascade Lake was assured, and that close attached storage guaranteed the low latency that you'd require for database workloads. And there's a huge performance difference. I found the M5D probably to be the best value in the AWS space for low latency workloads.
Great. Stephen, this has been very insightful. I mean, I think people will really be able to use some of the advice that you've given. Sounds to me like the major advice is test, benchmark, benchmark. I mean, of your own workloads, find out which ones. And it sounds to me also like you can't just test it once. You've got to test it multiple times, because if you have a workload that needs to be highly predictable, that's it. You gotta find the right mix to get this.
Absolutely, you can't be ignorant of what goes on in the cloud. You really have to get smart pretty quickly, or look for the help to get there. And it can really drive a lot of value for you.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.